this video, you will learn more about how reference measurements are conducted in the field. The team at the University of Munich is loading their gear into the vans, including spectrometers, LAI meters, chlorophyll meters, storage devices for collecting biomass samples, and yes, also simple tools like a folding ruler. The weather is fine, the sky is cloud-free. This is going to be a good day in the field. The vans are heading to a test site called Munich North Isar, which is located in an agricultural area north of Munich, where the LMU team conducts experiments on a regular basis, and in particular, ground-based reference measurements. Once they arrive at the test site, the team immediately starts unloading their equipment. Although all the field equipment is packed in robust cases, the instruments need to be handled with great care. Ready? Good. First, access or make sure that you are at the exact location you plan to be at by checking its GPS coordinates. Then, it is always a good idea to take photos while the sampling sites are still undisturbed. Decide in advance what kind of photos you might need. For example, close-up nadir shots, as Matthias is taking here. You don't always need fancy equipment. Marco is measuring plant height with a simple ruler. Even though crops grow at fairly even heights, he measures several plants to calculate an average later. Just as important as the measurements themselves are the notes that Stephanie is taking in the background. Best practice is to develop a field protocol sheet so you don't forget to record a measurement or ancillary information. As plants are very sensitive to climatic conditions, and every year is different, Toby carefully assesses the phenology, which in this context means the development stage of this wheat plant ear. Besides, counting the number of grains per ear gives a good estimate of the expected yield. By gently squeezing the grains and by probing them with a fingernail, the hardness of the grains is evaluated. Monitoring the gradual decrease of moisture in the grains is important. Winter wheat should not be harvested until the grains are very hard and residual moisture is 14% or below. Now, let's make use of the fancier instruments and look at the leaf area index, or LAI for short, which is one of the most important parameters for canopy architecture. LAI is a dimensionless factor that describes the overall leaf area of a canopy at a vertical extent to the corresponding horizontal footprint, e.g. meters squared per meter squared. Katja can determine LAI in situ without the destructive removal of biomass by using indirect methods. Lycor plant canopy analyzer LAI meters have become the standard instrument used in many applications. They measure diffuse radiation, i.e. transmission, underneath the canopy in combination with measurements above the canopy to serve as reference. When set up for use in the field, this instrument is comprised of at least one sensor arm and commonly a control unit. When equipped with two AA batteries, one sensor can measure the LAI in an autonomous mode and store values on the internal memory of the instrument. First, Katja takes an above canopy reading, followed by a certain number of predefined below canopy reading, usually about 4 to 7. This procedure is repeated, if time permits, 2 to 3 times per site. For details on how many measurements to take, what to consider when measuring row crops or tall canopies like maize, please refer to our field guide. Chlorophylls are a dominant factor controlling leaf optical properties of healthy green vegetation, and hence provide useful information about photosynthetic potential and primary production. Quick, non-destructive, and accurate techniques to estimate the chlorophyll content of vegetation are of significant importance to agricultural management operations. Here, Katja uses the handheld SPAD 502 Plus chlorophyll meter to measure relative leaf chlorophyll content by means of an index. Absorbance of LED light by the leaf at 2 different wavelengths in the spectral domain of red and near infrared is measured. In the domain of red light, chlorophyll absorbs light strongly, and in the near infrared, reflected light records differences in leaf structure. With these two values, a company-defined SPAD value is calculated by division of light transmission intensities. Overall, we recommend measurements on 5 to 10 leaves per plant. Leaves should be fully intact, clean, dry, no visible moisture on the surface, green, and free of signs of disease or damage, and special parts like the midrib or major veins should be avoided. A minimum of 5 measurements per leaf is recommended. And finally, we will cause some destruction by harvesting a couple of leaves to assess leaf mass area, or LMA for short. This is an important variable as it indicates how much biomass the plant invests in the development of leaf area. And a little more by harvesting all plants of a defined 50 by 50 centimeter area to assess the canopy water content. Come and join us in the next video to see how the samples are processed in the lab.